Hello and what's up to you all pre-matriculants. My name is Abram and it is a lovely Monday. We call it our Triple M Day, Mind Cities Math Monday. And I hope that you guys enjoyed your day at school. I'd like to know from you, what were you doing at school, especially on your math class? Well, we're going to be having a great show. Let me tell you how to get connected with us. Log on to your Facebook right now. Our Facebook address is facebook.com/Learn Extra. All our Learn Extra is an XTRA without an E. So even on Twitter, you can follow us at Learn Extra. I'd like to get your tweets, your comments about the show, and your questions, of course, because we're here to help you guys. We also have got some awesome giveaways through our Test Yourself questions. If you get to answer those Test Yourself questions, you could win this awesome Casio calculator. I'll be announcing the winner later, but let me greet our teacher. Dina, how are you?
Hello, Abraham. Doing very well this afternoon, everybody.
Awesome. Happy spring month, our new month.
New week, new day, new month, new season.
New season.
Just 4 news.
Nice one. I hope you're good. What are we doing with the Mindsetters today?
Well, today we're doing that most exciting topic called finance, the real topic for real life. We always want to do, why do we do all this trig and algebra where we don't use it in life? Well, here's a topic that's real life, so hopefully we'll enjoy it.
Is it more similar to Maths Lit?
No, it's not maths lit
So
at
it's
all.
not that real.
No. It's lots of words, and people often say when you have lots of English context comprehension, it's maths lit, but it's not really.
It's not real. Well, Mindsetters would like to get in touch with you guys. Send us your questions. I'm sure we're also going to be challenging you guys. So there's a lot of things that are happening around, but all the information and the links are on facebook.com/LearnExtra. One last thing, if you miss any of our notes or any of the shows and you'd like to go back on them, go to learn.mindset.co.za. We have a schedule with the video and the notes to download. Back to you, Tina.
Thanks, Abraham, and welcome all grade 11s. We really are looking forward to working with you this afternoon. So let's get going. I am going to skim through the notes because I really want to get to the examples, because the examples are often times where we really learn about those concepts we haven't yet grasped. And I know that you've done this since grade 9, the simple interest formula, the compound interest formula. So nothing's new in grade 11, except for one aspect of the compound formula. And we will look at that in terms how the rate and the compounding periods change. So we'll look at that very briefly in the notes, and then we'll head off to the questions. And while we're doing that, I'm hoping that some of you will really take the challenge question and try it out, because it really is a simple one with a little bit of a twist there. So we'll look at that at the end of the show. So to the notes we go. So we are going to revise the definitions of simple compound interest. We're also going to work with the formulae for appreciation and depreciation to calculate interest. And this brand new thing to you grade 11s will be, how do we calculate a nominal, and what is a nominal rate and what is an effective rate? Right, here's the challenge question. We have 2 guys, Dumasani and Stephen, and they've started a trucking business in their spare time. Their first truck costs 650,000 Rand. It depreciates at 30% per annum on a reducing balance. In 4 years' time, the truck must be replaced, and the new truck price is appreciated 15% per annum. What will they have to pay in after 4 years if the current one is used as a trade-in? So simple mathematics there, and I'm sure you're going to have some fun working through that. Why don't you post your answers? Let's see which of the first, who's the grade 11 to be the first one with that answer on the page.
A correct one, Dina.
The correct one, yes, thanks, AB. Right, so we've worked with this, like I said, over the last 2 years in grade 9 and grade 10, the simple interest. A is always the amount that you have at the end of a compounding period. P is your principal into 1 plus I, N, I being your rate, and N is the number of periods. So that's straightforward. It also applies to compound interest. Same thing, but instead of compound interest having times N, it's actually incorrect there, it should be A equals P into 1 plus I, and compounding always means that the n is the exponent, not the coefficient. So again, we still have p is the principal, I is the rate, and n is the number of periods. Okay, then we have something that is a little bit new. When we have an annual rate and we are compounding over a year, we talk about an annual rate, and it's calculated and added at the end of each year. Semi-annually or half-annually means that if I invest, let's say, 1,000 rand, then that 1,000 rand is going to accrue interest over 2 times or over 2 periods within the year. So we're not going to do an annual calculation, we're going to do a half-yearly calculation on that interest. Then we have quarterly periods, which means that's every 3 months, because for every 3 months that constitutes a quarter of the year. So some interest is calculated every 3 months. And then we really have this one, which is quite the one that's often used when you're making investments: a monthly interest rate, which is calculated every month, or a daily interest rate, which is calculated on a daily basis. Okay, so we want to get to depreciation. We know is always when you lose value on an asset. For example, a car, a truck, computers, all those kind of items lose value, and you want to know how much will they depreciate in value over a period of time, and we'll look at those calculations as well. Then the book value is the value of the asset after the depreciation is taken into account. And very often you'll see that a car is bought for a certain price, and if you want to resell your car, you want to know what its book value is. And we use a depreciation to calculate that. Now, grade 11s, what's really, really new for you is a nominal interest rate. Is one where the interest rate quoted and the compounding periods are different. So, for example, if we're going to charge you 12% per annum compounded quarterly, I'm going to write it as an abbreviation, and you'll see very quickly what's happening. The rate has been quoted as an annual rate, but because you're wanting to compound every quarter, we need to work out a quarterly rate. And so this is the nominal, it's the expected rate. But the effective rate over that year is actually going to be slightly higher if you work out the annual effective rate. So when the interest rate quoted and the compounding periods are different per annum compounded quarterly, that is a nominal rate. Now, grade 11s, when I take that rate and I say 12% per annum means that if I'm going to compound it every quarter, that 12% I need to divide by 4. So 12 over 100 divided by 4 would be my rate per quarter compounded quarterly. This is now what we call an effective rate, because my rate and my compounding periods are the same. So when they're different, annum, quarter, annum, half-yearly, annum, monthly, effective means that you're actually getting the same rate. The rate is in that compounding period. Now, it is common practice to quote interest rates per annum, but the compounding period can be quarterly or monthly, excuse me. These interest rates are called nominal interest rates. An effective rate, as we said earlier, is one where the rate quoted and the compounding period is the same. So 12% per annum compounded annually, 1% per month compounded monthly, 2.5 per quarter compounded quarterly. And the formula that the equal sign is just a little bit in that bracket, it shouldn't be. But the formula that gets you to an annual effective rate is your quoted interest rate divided by m to the power of m, where this is over 1 year. So that formula will help you in converting between effective and effective annual and effective monthly or half yearly, etc. Okay, Taboo sells, let's see what the first question is about. Taboo sells his business for 430,000 Rand when he is 32 years old. He then decides to save that money for his retirement. He deposits the money into a pension fund where the interest earned is 14% per annum, compounded annually. Calculate how much money he will have saved by the time he's 65, assuming that the money was invested for 33 years. So when you are first given the problem, you need to understand what the context of that problem is about. And so you need to read it just to establish, okay, who is it? What is happening? Okay, so from what we've read, we can see there's a person who's got a lump sum of money, puts it into a pension fund, and then leaves it there for an amount of time. So you get the broad context of that problem. Now you're going to dig deeper, and you're just going to read again to make sure that you extract the details. So if we go back to it, we want to see, right, this now has got some mathematics attached to it. That's the p-value, number one. And he decides to save, he deposits the money into a pension fund, and the interest rate now is very, very important because the interest that's given is 14% per annum compounded annually. So this basically does two things. It tells us that we're going to use the compound formula, and number two, it's giving us an effective rate because it's giving us per annum compounded annually. So I don't have to work anything out because it's already an annual rate that's been compounded annually. So it's giving me the P, it's giving me the I, and it's also giving me that this money is going to be invested for 33 years. So I've been able to extract out of my formula those key three things in order to work out how much money he would have at the end of the investment. So my formula for compound interest, first of all, is 1 plus I to the n. Okay, and if I get all my values as I've done from the extracting of that context, then I know what my P is, I know what I is, I know what N is. So P was 430,000, and then I've got 1 plus my rate was 14% per annum. And then I would like to invest it for 33 years. So how much do I have at the end of that period? I have a little machine here that will be able to work it out for me. Let's go for 30,000. Okay, maybe not. Okay. Let's try again. Okay, we'll need to get somebody to just look at our calculator and see why it's not working. So that would be my value if I multiply by that factor, which is 1,14 to the power of 33. So it's going to increase quite substantially. Maybe can you just ask somebody to tell me what's wrong with the calculator?
All
Thanks. Right. Now, what we're going to do, just to look at another effective rate, is to say, let's assume that this person was doing the same thing, but he was actually compounding monthly. So the same rate, but over a monthly period. How would that change? So Taboo stays the same, 430, but we're going to now say we want to compound that monthly. Okay, so I'm going to just add on Taboo's deposits same amount, and but at the interest rate of 14% per annum compounded monthly. And we'll say also over 33 years. How does that calculation change in relation to my new piece of information, which is this 14% per annum compounded monthly. Okay, firstly, if I'm going to be compounding monthly, just think about it. Every month, I'm going to be working out the new rate. So I'm not going to be giving you 14% per month. I'm going to give you a 12th of that. So it would be, our effective rate would be 14% every month. So I would take a 12th. So this would be per month compounded monthly. Alternatively, you could look at this rate in the following way. It's 14%, so it's 14% divided by 12. Okay? Or you could look at it as 1/12 of 14%, whichever way you like it. These are all the same thing. I'm taking 1/12 of 14%, so this will be my monthly rate, and this will be per month compounded monthly. So it's about just over 1% per month compounded monthly. So my I has changed, but over 33 years, I'm now calculating an interest rate that is a monthly rate. So my N is not going to be 33. It's going to have to be a value that is in months. So, in other words, since this rate is a monthly rate, okay, this becomes a monthly rate. Okay, these are the same thing, it's a monthly rate. Then my N is now going to be in months. How many months are there in 33 years? So that would be 33 times 12. And we now have a new N and a new I. But the formula stays the same. It's A equals 430,000. 1 plus my new, whichever one you like, I like 14 over 1,200, to the new N, which is 33 times 12. And I can just use my calculator and see by how much has that changed. And in that way, we've been able to adjust the rate and the compounding periods. So just to summarize, if my rate was done per quarter, then my N would be in quarters. So there are 5 possibilities of being able to compound: annually, half-yearly, quarterly, monthly, or daily. And what you do to the rate, you must do to the compounding periods. So if I'm working with a quarterly rate, I must work with quarters. If I'm working with a monthly rate, I must work with number of months, etc. Make sure that the effective rate actually balances up with the number of compounding periods. So I think we'll take a quick break there. Back to Abram.
Thank you so much, Dina, and thanks to the masters that have been helping you, Dina, giving us the answers. Thank you so much, guys. Remember, you can still, if you don't have a calculator, you can still answer the test yourself questions, and you could stand a chance of winning this awesome Casio calculator. We'll see you after the break. Welcome back, awesome pre-matriculants. Now I see that some of you are a bit late, like Wendy, Monama. You can still join us. You're not that late. And welcome up here, Morgan Makatini, a regular mindsetter. Also help one another, guys, on the page, because that's what we want you guys to do. Otherwise, we do have a mobile mathematics to help you. It is More Maths. All you need to do is to register on moremaths.org. Your code is I2IK. I2IK, and all the information is on our Facebook page. It is a cool and great application to help you more on finance and to challenge yourself, and also to be challenged by other mindsetters by setting up a good score. So for now, I'll be also looking at the challenge question answers that we have. Keep them coming, guys. Dina?
Welcome back, grade 11s, and guess what? I've got a calculator, so I've got some answers for you. So let's have a look at what happened in the previous question. We had a 430,000 grew to 32 million over 33 years. But wait, look what happened. If you compounded monthly, it grew to 42 million. So it grew by another 10 million. So the idea is, if you're going to invest money, try and find an investment institution that will invest your money over every month, because it's actually the best rate is to actually get it over a month. I'm sure you can begin to imagine that if we did the same thing, but over a daily rate, I'm sure we would get much more. So isn't that exciting? The maths is speaking to you, and it's telling you, or it's empowering you how to make these decisions. We would like to have money being invested over a monthly period. Okay, so let's go on to the next question. Next slide. Right, we have a scenario. A car rental company buys a fleet of cars at a cost of 3.2 million rand. Calculate here's a word, the book value would be the resale value of the fleet of cars after 5 years if the depreciation is calculated 6% per annum on a reducing balance. So we know that we've got a fleet of cars, and they are worth a certain amount when we purchase them, and then they will reduce in value. They will not be as valuable as when we bought them. Okay, so we've got the context, a fleet of cars. Now let's go and dig for the mathematics that will be helpful. Firstly, we want to find the book value. Then we know that we want it after 5 years, and we're talking about depreciation, so we're going to see that the A value is going to decrease, and we have a calculation, a 16% per annum, and then we've got this word, a reducing balance. What does that mean? Reducing balance, is it simple interest or compound interest? Compound interest. So all these words are very important. That refers to compound interest, so it's reducing via that calculation. So we're going to look at a fleet of cars, costs 3.2, depreciates for 5 years at 16% per annum. And we don't get an effective rate with depreciation. It's always an annual calculation on depreciation. Right, so let's look at that. We've got a fleet of cars that is 3.2 million. We have N is 5 years, and we've got I at 16% per annum. So we then use our formula, A equals 3.2 times 10 to the 6 multiplied by 1. Now am I going to put a plus or a minus if I depreciate? Okay, I'm not going to grow that value. I'm going to decrease it. So it's minus the 16 over 100 to the power of 5 years. And now I've got my magic machine, which hopefully this will work this time. So we've got 3.2 million multiplied by 1 minus 16 divided by 100. And we're going to raise it to the power of 5. What does that give us? The fleet of cars is now worth 1 million. Okay, so it was 3.2 million. It's now worth 1 million. So it's reduced almost by a third in value. So it's 1, 3, you can just write 1,3 times 10 to the 6. So it's approximately that. I'm giving an approximation. In your final answer, they would actually want it to the nearest rand. So it would be 1,338,000. 1,338,278 rand. So that would be the worth of the fleet of cars. Now, any company would want to replace machinery, fleets of cars, trucks, whatever you're working with. We want to be able to replace them. And the next calculation is calculate the cost of replacing the cars at the end of 5 years if the price of the new cars is expected to escalate at a rate of 8.5. Now think about what's happening. 2014, we have a fleet of cars. It's worth 3.2. In 2019, 5 years from now, that car that we have purchased is going to decrease in value. But companies are continuing to make new cars. So the ones that are being made new for 2019, they will increase in value. So by the time we get to 2019, the ones that cost us now 3.2 are going to be costing us a lot more. So that's what this question is about. Calculate the price of the new cars if we're expecting an escalation of 8.5%, which is just slightly in South Africa over the inflation rate. So things are going to be going up by that value. And we're saying, well, let's have the worst case scenario 8.5. Hopefully it doesn't get to 10, because the higher that value is, the more that those cars are going to cost us. So we then have the situation. I want to know what are my cars which presently they cost me 3.2. Okay, what are they going to cost me in 5 years' time if my rate is 8.5% per annum, compounded annually? And they cost me this now. Every year they're going to go up by 8.5. So how much are they going to cost me in 5 years' time? 3.2 times 10 to the 6. And I'm going to increase it by 8.5 over 100 over 5 years. So what does our magic machine have to tell us about that? Okay, I still have that calculation in there. So let's just go back in. I want it over 5 years, and I want an 8.5. And I want to add this time around. So I'm going to have 1 plus, and it's an 8.5 that I'm dividing by 100. Let's see how much will the fleet of cars. Look how much it goes up by. That is 4.8 million, so it's almost 5 million rand in 5 years' time that they will cost. So that will be, no, not rands, equals, A equals. So we've got A will be equal to 4,811,701. That's how much the fleet of cars will be. Now, if you think about, because that's how far the question goes, but if you think about selling those the cars that you currently have and purchasing a new fleet, you actually have a difference of, you back to 3 million. So by selling your old ones and purchasing new ones, you actually have a 3.2 million almost deficit, similar deficit as you had at the beginning. So Grey Levens, the whole idea around the finance is to be able to set up a sinking fund, a fund that you're actually saving into, so that by the time you get to 5 years later, you have the money to purchase and you don't have to take a loan. So that's the other aspect of this math that's very real. We're trying to save up for something that we want rather than getting loans, because paying back loans means that we're going to be paying for that debt as well at the same time. So we kind of pay double when we take out a loan. So the idea is, if you can work out how much your cars are worth, and if somebody can buy them from you, then you've got a little bit of money to pay as a deposit, so that the remainder of that money you have saved over time, so that you have the cash in hand and you don't have to get a loan, which is the ideal in this world that you're trying to aim at. Right, let's look at what Kate's doing. Kate deposits 3,500 into an account. 3 years later, she adds another 4,000 to the account, and she's got an interest rate over the first 2 years at 8% per annum, and thereafter the interest rate changes. So we see, just from the context, something interesting happening. There's a girl, she deposits some money, she deposits another lump sum, but the interest rates have changed over that period. So we've got to accommodate for what's happening in that account. Okay, so let's read to extract the maths. So we have a deposit of 3,500, and 3 years later she adds 4,000. So here's some information that's quite useful. Then the interest rate for the first 2 years is 8% per annum, compounded monthly. Thereafter, the interest rate changes to 10% per annum, compounded half yearly. Calculate the value of the savings at the end of the 6th year. Okay, grade 11s, I think it's useful to always set up a little timeline that indicates the period over which we are working. So we make a deposit at T0, and then that takes me to the first year, to the second year, to the end of the 3rd year, end of the 4th year, end of the 5th year, end of the 6th year. So we make a deposit of 3,500 Rand. And over these 2 years, this rate has been given to us as 8% per annum, compounded monthly. And after that, 3 years later, she places an amount over here of 4,000 Rand. And this rate over these 4 years is 10% per annum, compounded half yearly. Okay, so we've extracted all the maths, we've put in all the values that are useful for us. One deposit over that much, that deposit over that much, but the yellow period is monthly and the blue period is half yearly. So notice I don't have an effective rate. I first need an effective rate because I can already see it's per annum compounded monthly, and I can do nothing with that. So I'm going to quickly say that my effective rate here will be 8% is over 100, but it's going to be monthly, so it's going to be per month, compounded monthly. So this is now going to help me in my formula. And over here, it's half yearly. So if it's half yearly, it's 10%, 10 over 100, but I'm going to do it twice. So I want 10%, half yearly would be divided by 2, so it's 5% per half year. So that would be per half year, compounded half yearly. So that's what I'm going to be using in my formula. Okay, grade 11s, I want you to be able to break it up in your head and understand how the maths is working and how many calculations you would need. But I also want you to be able to construct your formula. Write it out, and then use one formula on your calculator. So if there's errors, you can go back and adjust it, because the calculator is quite constrained in its ability to delete and correct. And so you don't want to start all over again with your formula. So let's try and construct the formula. We have 3,500 Rand that stays in there for 2 years at that rate, so it's going to grow by that much. But after it's grown by that much, that becomes your new P. And that P is then going to grow at 10% per annum compounded half yearly. So we really are going to set up one formula that basically says this. My 3,000 Rand, actually I'm going to start with yellow, my 3,500 Rand is going to grow at 1 plus 8 over 1,200. Grade 11s, this is a monthly rate. Every month I'm getting this rate. How many periods will there be in my 2 years? There will be 24 periods. So I'll literally calculate first month, second month, third month, 24 times I'm going to work on this principle. And then my money stays in there. Now this becomes our new value. This A becomes our new P. And I'm going to grow that now 10% every half year. So it stays in there for 2 years, it stays in there for 4 years. So this becomes my new P, which I'm growing at 10% per half year. And grade 11s, how many half years are there in 4 years? There would be 8. So I'm going to calculate my interest 8 times. So that's how many periods there are. That's my half yearly rate. So see how I've constructed that formula to indicate that this is my new P. So I haven't gone into a new calculation and said A equals my new P from the calculator, and then I multiplied by that. Because the more values you're writing in, the more confusing it becomes. So try and construct it as one formula, understand what the formula is doing, and then punch it into your calculator. Much, much easier to do that. Because if you've then made a mistake, you can see it straight away. You want to know where the mistakes are going to occur. Here, have I got a monthly rate? Have I got the right number of periods? Have I got a half-yearly rate? Have I got the right number of half years? So you then can check that for accuracy, and you can go back to your calculator and just enter it. And notice, I haven't used my calculator at all because I'm trying to construct that formula. Now, I'm also going to add onto that, I'm going to add this little bit here that I've entered in my 3rd year. So I'm going to add 4,000 onto that, and it's only going to grow at 10% half yearly. And how many half years? And we just double check that we've got this right. 3 years later. So 3 years later means I'm going to have 1, 2, 3 years to work with, and 3 half years, or 3 years, means that there are 6 half years, or 6 periods that I'm going to be compounding that for. Once I've got my formula, I can now go to my calculator, and we'll start with my 3,500 that I'm going to multiply into 1 plus 8 divided by 1,200, and that's to the power of 24. And then I'm going to multiply that by 1 plus 10 divided by 200. And that's all to the power of, let's come this way, 8. And then I'm going to add on my 4,000 and multiply it by 1 plus 10 divided by 200, which is to the power of 6. Power of 6, not coefficient of 6, right? And I can now give an answer. Now, if I've made any incorrect thing here, I can go back and edit. I've got space there. So I've got 11,425 Rand at the end of that period. So A is equal to 11,000, already forgotten what it is, 425 Rand. Okay, now isn't that amazing? Over the 6 years, we had 7,500, which has grown to 11,425. And if you look at the calculation we did previously, we saw that if you do a monthly calculation, you earn more interest. So I'm not sure why she chose to do a half-yearly calculation, but that is the context that was given to us. Then we'll take a pause there. Back to you, Abram.
Thank you so much. And the question is based on that question, which we'll take after the break. You also have the challenge question, mindsetters. I see your questions. We're not ignoring you guys. After the break, I'll also be announcing the Casio Calculator winner. See you after the break. Welcome back, Mindsetters. Awesome and great news are the winner of the Casio Calculator from the last week's show is Jamie Leah Williams. Congratulations to you, Jamie Leah Williams. This awesome calculator is coming your way. If you'd like to enter, answer the test yourself questions right now, Mindsetters. But still on the giveaway mood, we also have the draw that will be taking place on the next show at 6 o'clock. So do watch. We'll be giving away the Sony Xperia L cell phone. So if you've been entering the Get Connected competition, you could be the winner for the Sony Xperia L cell phone. So stay tuned for the draw on the next show. But it doesn't end at dinner. I've got exciting news. Just before I give it to you,
yes.
We've got this awesome competition that is coming up. It's K53 with Mindset TV. We're giving away a car. So
Can I join?
General
Can I
Motors,
try?
no, there are terms and conditions which you'll find on the, more information is going to be given to you guys, but the competition is opening on the 15th of September and closing on the 15th of November. So guys, do stay tuned. But if you are in process of obtaining your learners, or if you do have your learners, we're encouraging you guys to be drivers. So it starts right now on your grade 11 and grade 12. So guys, keep it tuned in right here on Learn Extra and Mindset TV.
Learn Extra gets better and better. All these extra goodies arriving. Now it's a car, grade
Yeah,
11s.
a car.
Wow.
Hey,
Can
yeah,
you believe
wish I
this?
can enter too.
What planet are we on? Right, grade 11s, we've got a little bit of time, and few of you have been asking about how am I getting those effective rates. So I'm just going to briefly go over that because that is such an important concept for us going forward as well when we work with annuities next year. So let's go over that sort of in the slow motion phase. Okay. So earlier on, we had an 8% per annum compounded monthly. We had a 10% per annum compounded half yearly. And you wanted to know where the denominators were coming from. Now, this rate, I'm going to try and explain it nice and slowly. This rate here is an annual rate. But because you want to have the rate occurring every month, or there's got to be a monthly rate, because we want a monthly rate, okay, I hope that everybody's with us there. How do I know I want a monthly rate? Because I'm told that I've got a compounded monthly. That's telling me what to do. I then am sitting with a situation that says, hang on, you're getting 8% per annum. If you were going to calculate, let's say, 1,000 Rand over the year, you'll get 8% on that 1,000 Rand. But what you're not going to get is 8% every month. Otherwise, we'd all be super rich, and I wouldn't be teaching you mathematics. It would be unnecessary. So the 8% over the year has got to be divided a little bit into every month. So we want a monthly rate, which means I want to take a 12th of 8%. That's really what I'm doing. How much is a 12th of 8%? Okay, 12th of 8%, everybody with me, is 8% divided by 12. That's your monthly rate. So if we had to quickly look here and divide 8 divided by 12, you are effectively getting 0.666% per month. That's what you're getting. So your monthly rate is actually a 0.6 recurring percent per month, compounded monthly. Okay, that's really what's happening. It's 0.6%. Now, when I'm putting it into my formula, I want to make sure that I've got all the right values. So instead of having 0.6 into my formula, because I don't know if I've extracted the correct percentage into the correct denominator, what I do is I say, hang on, it's 1/12 of 8%. Grade 11s, what's 8%? 8 out of 100. So that makes it 1/12 of 8 over 100. Hence, that gives me 8 over 1,200. Now look carefully, that 0.6 recurring, 8% out of 12, 1/12 of 8%, 1/12 of 8 out of 100. All these mean the same thing. I have chosen this one because on this one I can see that I've got 8 out of 100 and I've taken a 12th out of this. Because 8% is a fraction and 1/12 out of that is also a fraction. So we multiply those two denominators, we get 1,200. Hopefully that settles that one. What about 10% per annum? We're doing the same thing. It's an annual calculation, but we want to compound it every half year, where this means every half year. So, what kind of a rate do we want? We want a half yearly rate. What does that mean? That I have to take my current rate, 10%, and I've got to say, I want a half of 10%, which is 5%. Now that's the same thing as saying a half times 10 out of 100, which is 10 out of 200, which is 10 out of 200. So that's 1/20th. and that will be your half yearly rate. Just checking that's half of 10 would make you 5% per half year. So this rate here would be per half year compounded half yearly. So there is in a sense, there is, that 0 goes in there, and that's 2 times 10, which is 20. That's correct. In a sense, there is a pattern forming, and that is when it's per month, you take the number of months and you times it by 100, and that becomes your new denominator. If you take 10 out of 100, you multiply it by 2 because you're doing it twice. So your denominator will always be accommodated. But if you want to do the maths, you can write it out. It's a half of 10%. So it would be a half times 10 out of 100. And that would be your 10%, which would be 5% as your 1/20th. So hopefully that has helped to those of you who still haven't gotten that quite or grasp that concept. Why don't you go back through the notes again once more and just go through it again and again until you really get it. Does that help the mindsetters?
Yes, it does.
Good. Any other queries before we do the challenge question?
I think let's do the challenge question, and I'll give you this question
cool.
after.
Let's go to the challenge question. How many mindsetters have answered the challenge question?
There's over 26 responses.
Okay, let's see.
Actually, 31.
Duminisani and Stephen have started a trucking business in their spare time. Their first truck costs that, and it depreciates at 30% per annum on a reducing balance. So there's our starting value. Depreciates 30% per annum on a reducing balance. So it's telling us the rate, annual rate, compounding. So that's its new value. So its new value is going to be 650,000 multiplied by 1 minus, it depreciates at 30% over how many years? In 4 years' time, the truck must be replaced. New truck prices appreciate 15%. What will they have to pay in after 4 years? So how much is it worth after 4 years? And that will be its book value, if I can talk about book value. So if we quickly adjust this here and write in here the A of the book value. Okay, will be that much. And then we want a new truck. And they increase at 15% per annum. So whatever it was, whatever the truck was worth, so this will be the new truck, it's 650,000, but they're going to increase, they're going to inflate by 15% over 4 years. So the question is, what will they have to pay in after 4 years if the current one is used as a trade-in? So they're going to sell or resell their vehicle, and they're going to get that. So let's work with our magic machine here. And at 650,000, we're going to depreciate, so 1 minus 30 divided by 100 to the power of 4. And I'm then going to find that this number is bigger. So minus 650. And we're going to appreciate or inflate that by 15%. And we're going to do that over 4 years. No, not simple, but compound. So it's to the power of 4. And we actually get that it is, they have to pay in 183,239. So here you'd have a value, which I haven't asked my calculator to give me, because you can do it all as a one calculation. And here you have another value, which you can see in a moment. But what they really, the question's asking is, how much do they have to pay in? So they would have to pay, what was our value here? 183,000. And 239 to the nearest rand. Is that what mindsetters were getting?
Yep. I do have those.
Nice, great level.
Nice
Very proud of
ones.
you, very proud of you.
Wow, well done, mindsetters. And others were getting, so many other different answers.
Okay.
But well done.
Good. So let's maybe do one last question. Have we got time for one more?
Yes,
Let's
Quickly.
choose a nice quick one. If we look at this question where,
Or else, can I give you this question from the
yes,
mindset?
let's do that.
Here's
Yeah.
a question from Tukela saying, what formula do we use when asked to calculate the period using simple decay? Don't we use the one that has log?
Well, it depends. Yes, if you're wanting to know how many. Okay, so the question is, if you're working on decay and you're wanting to know how many periods it takes for something to decay, then you are solving for the exponent. And grade 11s, you could, by trial and error, solve for that exponent, because at this stage you haven't yet looked at the notion of logs. So next year you will, and you will certainly be able to do that. But for now, you could actually approximate. You would get your base, and you'd be able to work out roughly how many periods. So if you were to solve for an exponent now, best way, trial and error. But next year, certainly logarithms, which I won't go into at this stage.
Okay, well, thank you so much, Gina. That's
Pleasure.
a wrap.
That's a wrap. Cool.
Cool. Thank you, Mindsetters. Remember to stay tuned for the draw that we're going to be doing after this show for the Sony Xperia L cell phone, proudly sponsored by Vodacom. We love you guys and see you next time. Peace.